Hello everyone. Today I am going to discuss about force, the only external factor by which the stationary body can move or a moving body can be stopped. Yes, the force only can move a stationary object or can stop a moving object. Okay? This external type of force can be of two types, balanced and unbalanced. When, just for example, the body is attached with a rope in both sides. Okay, here is a diagram. This is a body and this side rope and this side rope. Okay. The force is applied here in two sides with equal amount, okay, in this way and in this way. This type of equal amount of force in both sides cannot make the body moved, okay. The position cannot be changed here. Only what can happen, there can be a change of shape of the body, okay. Just for example, this is a balanced force. When this is an unbalanced force, this is a body. Someone is pushing the body in this direction and the body is attached with this floor by friction. The friction acts on in the opposite direction. So the person has to push greater force, okay, but after some time the body can be moved in this direction. The force is applied on this direction, friction is acts on in the opposite direction, and finally the body can move in the forward direction, okay. This is unbalanced force. Unbalanced force can be applied in one direction only, okay. Now, about force, motion, inertia, scientist Newton discovered three types of laws. Okay, this is the main part of my today's discussion. Okay, this is Newton's first law, second law, and third law. Newton's first law is associated with a term inertia. Okay, Newton's first law and inertia. Then Newton's second law, and this is the mathematical deduction, and last the Newton's third law. First, I am going to discuss about Newton's first law. Actually, the body has a tendency to stay in states of rest or in motion. The body, if the body is in rest, the body has a tendency to be in rest. If the body is in motion, the body has tendency to be in motion until what? Until external force is applied on it. This type of, this actually the first law, this type of tendency of the body is called inertia. There is inertia of rest and inertia of motion. Okay, when this is inertia of rest, here is a funny example. Okay. The bus is stopped. Bus is in its rest position, rest state. Okay. The person standing inside the bus is also in its rest position. Okay. So, when suddenly the bus starts its movement, the leg portion, the lower portion of the body also suddenly starts its movement. But the upper portion of the body has the tendency to be in the previous rest position. So, in such a condition, the person has a tendency to fall backward. This is the inertia of rest, and this is the result of this type of inertia. Okay, and another type is inertia of motion. So just for example, bus is moving fast, and the person standing on inside the bus is also moving fast. Suddenly, bus is stopped. Suddenly, bus is stopped, so the leg portion, the lower portion of the body is also stopped suddenly, but the upper portion of the body has the tendency to be in uniform motion. So the person has a tendency to fall forward. This is the result of inertia of motion. There is another type of inertia when the bus is moving in a straight path and suddenly changes its direction along the curved path. The body of the persons, the body of the passengers show the tendency to go in the opposite direction. Okay, the bus suppose moves in this direction, the passengers, what happens, passengers go in the opposite direction from the center of the curved path. So this is type of inertia we can also notice in our day-to-day life. Okay, so this is the main examples, this is the main applications of Newton's first law. Then before going to the discussion about Newton's second law, I will tell about the momentum. Actually, momentum is what? The quantity of velocity. How much amount of velocity? Okay, the quantity of velocity possessed by a body is actually the momentum. Momentum is considered as small p, and small p is the product of mass and velocity. So the SI unit is here kg meter per second, because for mass is kg and for velocity is meter per second. Okay. So what is about the Newton's second law? Newton's second law states that the rate in change in momentum, please consider the term rate. Not only the change in momentum, actually the rate in change in momentum of the body is directly proportional to the force applied on it, and the direction should be the same at which the external force is applied on. So by this law we can have the mathematical deduction, the formula which is here. Actually, external force is F, which is directly proportional to the rate in change in momentum of the body. So change in momentum P2 minus P1. The initial is P1 and the final is P2. So change is in momentum is P2 minus P1, and the rate means ratio of momentum to the time. This is called rate. So this is divided here by T, and what is that? P is equal to mv. So when this is initial and final, so velocity must be u and v. So mv minus u divided by t. The common part is m, so we can write m v minus u by t, and finally v minus u by t actually changes the velocity to the change in time is acceleration, we told in the previous chapter. So ma, if proportional to ma, so we can get a constant k, we can add this constant k. If it is equal to k ma, we can get that k is equal to 1, k can be, the amount of k can be 1. So if k is 1, so F is equal to ma. For mass, m for mass is kg, and for acceleration a, it is meter per second square. So if external force can be measured by ma kg meter per second square, so this is all over this Newton's second law. Now what is the fundamental feature of second law is what? From second law we can get the idea of first law. How? Actually, from this part, F is equal to mv minus mu by t. So we can write F is equal to mv minus mu by t, and if t is equal to mv minus mu. If F is 0, if F is 0, from this formula, mv is equal to mu, and this m are delete it. So v is equal to u, and what is that? The final velocity is equal to the initial velocity. Yes, from this second law, we can get the last portion, v is equal to u when f is 0. Now, how this is a representation of first law? The first law says that, okay, from the first law, we can get the information that the body has tendency to be in rest or motion state when until external force is applied, okay, when there is no external force. This is the main part actually. When there is no external force, the body has tendency to be in rest or the body has tendency to be in motion. What is that? Here we can all notice that when external stimuli, external force is absent, means F is equal to 0. This F is equal to 0 is when external force or external stimuli is absent. What happens? V is equal to 0. Now V can be V is equal to U is equal to 0 or V is equal to U is equal to 2 meter per second. What is that? It represents that when V and U is equal to 0 means the body is in rest position. When V is equal to U is equal to 2 meter per second, it represents that the body is in a uniform motion. So this is the last portion of first law. This is the final representation of first law. What we can get from the second law. So we can say that from second law we can get the idea of first law in such a way. Okay, now I am shifting my discussion to the next portion, next topic, which is impulse. Actually, impulse is what? Impulse is the product of force with the time at which force is act on. Okay, how we can get this? Ft is mv minus mu. From this portion, Ft mv minus mu, from this we can write Ft mv minus mu. So we all can notice that mv is actually the final momentum p2 and mu is actually the initial momentum p1. So we can say that this impulse is the product of force and the time in which the force is act on, and it is also the change is momentum p2 minus p1. From this momentum we can get the SI unit kg meter per second. Okay, impulse SI unit is kg meter per second. Now the last point of our today's discussion is the third law. What is third law? Newton's third law says that the body can apply force on the second body. The first object can apply force on the second object, but the second object also rebounded the same amount of force to the first object in the opposite direction. Just for example is the propulsion of boat in the forward direction. Here we can notice the person pushes the water. The person pushes the water with a oar in the backward direction, and the water rebounded the same amount of force in the opposite direction to the oar. That's why the boat can move in the forward direction. In this topic we can get the idea is what the when first object applies force on the second object, the same amount of force can be rebounded by the second object to the first object, and the force amount is same but in the opposite direction. Okay, so this is all about our today's discussion of force and Newton's law for second and third, and obviously momentum and impulse. I think this whole discussion is going to be very much useful to your studies, and if you have any question, please write on in your comments section. And if you like this video, please subscribe this YouTube channel Knowledgeflame and go to the Play Store and download the Knowledgeflame app. Thank you.